they're all high quality and they're all low cost. But when you have 100 high quality, low cost parts and you add them up, they weigh more and cost more than an elegant solution that doesn't exist because you didn't put the effort in creating it. I think the technology exists, the processing power is adequate, the hardware is fine when it comes to cameras, radar, and LiDAR. The environment is the wild card.
Eine neue Folge von Innovation Pulse. Richard ist dabei, aus gutem Grund, denn wir haben einen wirklich, wirklich spannenden Gast, in dem wir tief in die Technologie einsteigen werden. Und er ist zugeschaltet aus den USA, deswegen wechseln wir jetzt ins Englische. So, Corey, welcome to Innovation Pulse. Thank you very much for finding the time.
Yeah, thank you for having me. I'm really excited for this.
So, of course, we know and watch so many videos of you about technology and so deeply into that thing. But let's start at the beginning. How did everything start? So why did you take the first Tesla apart? What's the story behind? How did everything start?
Yeah, it actually started in 2018, wow. 2 years before the YouTube channel. Monroe received a Model 3. It was actually for a study we were doing for a client, but the client canceled the study at the last minute. So we were stuck with a Tesla Model 3. Okay. And at the time, the Model S and the X were decent vehicles. So people weren't that excited about the Model 3. But when I met with Sandy, I was at Monroe as a director. I convinced Sandy that, hey, you should take a look at this. And some other people at Monroe didn't want to, but Sandy and I were aligned. So we did an internal teardown, meaning we didn't do it for a client. We did it just to learn. And the fit and finish was awful. So it was one of the first 1,000 vehicles. So the paint quality wasn't great. The gaps were horrible. But once we got into the high voltage system and the battery and the powertrain layout, we were really impressed because Tesla made a huge leap forward with integration. So the inverter, the motor, the gearbox were all integrated. The Penthouse, which is the high voltage charge module, the DC to DC converter, were integrated into the top of the battery. And those are things we love as engineers because you're eliminating waste. You're eliminating cooling lines. You're eliminating high voltage lines running from box to box. So it started in 2018. That teardown was covered by traditional media like Bloomberg and Autoline Detroit, and it got a decent press coverage. But fast forward to 2020, we ordered a Model Y, and that's when I convinced Sandy that we should start a YouTube channel for ourselves. And he was like, I don't know about that, because he didn't think we had the skill set to actually produce the videos. The pandemic hit, we tore down the Model Y, and since then, we've created 500 videos on Monroe Live, and we've torn down, I think, 6, 7, 8 full vehicles. So many people now know us from our current teardown videos, and that's kind of where we're at today.
So you are famous in the scene, if you want to say, but maybe you give a little bit background about yourself and also Monroe Associates for the few people that never heard of you.
Yeah. So 3 weeks ago, I actually resigned from Monroe and Associates. So I'm currently unemployed and looking for a job. I have a few opportunities on the horizon. So let's just clear that up. But I was at Monroe for 18 years. I started as an intern in 2005. So for 4.5 years, I was an intern, and I worked on various projects from construction equipment, airplanes, medical devices. Monroe is more than the automotive industry. Typically, about half of our revenue comes from the automotive industry, sometimes more, sometimes less. And then when I graduated, I got put on several long-term projects with Fiat Chrysler, developing the minivan, the Chrysler Pacifica, and that was from 2011 to 2015 or 16. And during that time, we benchmarked dozens of vehicles a year for that client. So myself and about 20 other engineers at Monroe become very aware of what's out there when it comes to interior trim and seats and chassis and body, not just the electric vehicles. So we build this huge, wide base of context, and we kept that hidden behind, the veil of all these projects. And it wasn't until we started the YouTube channel that we put not only myself, but there's other people like Scott Hoffman and Jordan and Carl. There's about 10 different people who come on the videos. People are blown away with the context that they can bring while doing a hoist review or an interior review. And most of those are zero preparation. There's no scripts. The car rolls in, it goes on the hoist, they walk underneath, and they just literally are freewheeling their interpretation of the structure. And it's quite impressive. The minds and the intellectual firepower that has been developed together at that organization.
What's your personal professional background? So what did you kind of study?
I studied mechanical engineering at Kettering University. Kettering University is in Michigan. It used to be called General Motors Institute of Technology. It's where Mary Barra went to school, the CEO of General Motors. It was founded in partnership with General Motors back in the early 1900s, and it since has split its association with General Motors. But it's a very good automotive technical school, and I don't know if there's an equivalent in Germany. I did study in Germany for 3 months at Hochschule Ulm. I don't know if I pronounced that correctly.
So we have Aachen. We have Aachen, where a lot of the famous executives of the big All right, perfect. So let's dive into the topic.
Yeah. So maybe before we start talking about Tesla, can you maybe tell us how many cars have you actually torn down in total over these 18 years? Do you know?
So I don't know the exact number, but it's in the hundreds. Hundreds. So for several years, we were doing 20 to 25 vehicles a year for, I'd say,
and all brands, like Chinese brands, Western brands, anything.
Yep.
A big knowledge base.
And it was over a long enough period of time that we saw the evolution from. We saw the evolution of the MQB platform. I saw the Audi D3 to D4 to D5 platform. I was able to study TNGA, Toyota New Global Architecture, as well as Toyota's old architecture. So that's kind of where you build that mindset, is you see old architectures and new architectures, and there's some really interesting things to be gleaned when you compare, let's say, Ford to Toyota. So Ford had the exact same air induction system on all their large cars. So the Explorer, the Lincoln MKZ, the Ford Flex, the Taurus. So sedan to SUV, the exact same common air induction system. Toyota, on the same platform size, had a unique air induction system for every single vehicle. So same size, but Toyota would tailor the air induction for tuning and everything. So they prioritized some sort of performance and NVH characteristics, while Ford was prioritizing cost and commonality. So it's really interesting to glean the different types of design methodology.
Okay, and now watching your YouTube channel, you get the impression that you have a very special relationship to Tesla, right? Since you tore down the first vehicle in 2018, if I remember correctly. So can you tell us, why is that? What makes this company special to you, or what does it make it stand out?
Yeah, the vehicles are designed unlike normal OEMs. So their traditional OEMs are crippled by vestigial thinking that's rooted in how they've always done it. So I believe it's a software-defined vehicle, and many of the solutions that Tesla has come up with are incredible because they're not relying on old standards. And a few of those examples are the park pawl. So inside the drive units, there is no park pawl mechanism. And if you're familiar
can
with
you explain to our listeners what this is?
Yeah. So a park pawl was invented for automatic transmissions, which aren't that common in Europe. It's more common to have manuals in Europe. So when you park an automatic transmission, you press a button or you put it in park, and it's a locking ring with a powdered metal target. It's a target ring with a powdered metal thing that comes in, and it locks it so that your car doesn't roll away. It's the mechanism that keeps your car from moving. It locks it, it parks it.
Yeah.
All of those components cost anywhere from $25 to $40. And that is how automatic transmission vehicles are put in park. Well, when EVs were launched, they have typically most are single gear direct drive. So there's no transmission. It's just a direct drive, typically 7-to-1 to 9-to-1. And the Chevy Bolt and the BMW i3 and many of the Fords and Hyundais, they put the parking mechanism from an automatic transmission into that. But how does a manual transmission vehicle work? There is no park pawl. You pull the handbrake and you turn it towards the curb. So legally, you don't need it because you can park the vehicle by securing the handbrake. But many of the OEMs were too scared. They thought there was legal repercussions. So they were including this $35 mechanism in all of their vehicles. Everyone sold $35. And it adds rotational mass, including dead mass as well. And Tesla, when they launched the Model 3, no parking pawl. They just rely on the EPB. Same thing with Model S and X. So no parking pawl. And just now, finally, traditional OEMs are feeling confident enough to remove the parking pawl. This may seem like a small thing, like, well, who cares? What's really important is every gram matters, especially when it's rotating mass. And a lot of the traditional OEMs, it's death by 1,000 tiny bad decisions, why their MPGE is so bad. And you can look at the thermal systems as well. Tesla designed their thermal system similar to how someone would design a circuit board. When you design a circuit board, you continually rearrange the circuits to get the best pattern so the board is as small as possible. You want to reduce the amount of material used. You want to reduce the resistance in the electrical paths. That's how they designed their thermal system with the super bottle and then the octo valve. Everything is pointed in the right direction, all the lines, and it results in 1/3 the amount of cooling lines and fluid compared to a traditional OEM. And these are the things that really impress us. And now you see other OEMs emulating that. But why did it take Tesla, a company that had never made a vehicle, they never made a vehicle until 2011 or 12. They've now leapfrog ahead when it comes to integration and efficiency of design.
Yeah, I mean, this probably comes down to the culture, right? The culture of the people they hire, the culture within Tesla. Can you tell us about the differences there? So how does a culture of, let's say, a Volkswagen compare to a culture at Tesla? Do you have insights there?
Yeah, and it's not just Tesla. I think there's other EV companies out there that are doing some great things in the powertrain. You have Lucid, which has an incredibly efficient driveline. I believe their Pure was just rated at 4.74 miles per kilowatt hour. And I apologize to your audience. I don't know what that is in kilometers. So
the times 1.6, but never mind. It's that's fine.
Yeah. And which is absolutely incredible. And oftentimes I think you have to have a startup mentality where the organization is flat. Because if you're built with a lot of hierarchy, that's where decisions and fast thinking go to die. If you have mid-level managers and high-level managers, because typically we've seen this, people will choose their career over the car. And I don't have a lot of experience interfacing with VW, but I do have a lot of interface with General Motors. And when I talk to employees from General Motors who are friends of mine, I'll say, hey, how's it going? I haven't seen you in a year. And they'll talk about their role, their level, their promotion. They talk about themselves. Like it's a very myopic view. They're like, oh, I'm almost a level 8 and I get a car and oh, I went on this trip. And if you talk to somebody from Tesla or from Lucid, they are passionate about their vehicle, the car. And oftentimes you'll see people at larger organizations prioritize their job security or their promotability based on low risk. So risk tolerance is low. They want to do what works, but do they want to actually eliminate their part? And that's something that I really think is crazy to think that there is a design and release engineer that most likely releases the PTC heater on the GM products. And for him to go to the architecture lead and say, we can design the whole system to eliminate my part and my job. They think about it differently. So that person is probably protective of their job and their component. And they're less likely to actually think of the vehicle as a living, breathing system that would be better off by the elimination of parts that should not exist.
There's no incentive to taking risks. So I counted this when I sold my first company. We did a software for online photo services, and we were a startup. But in the end, we had over 100 million customers, and then we sold it to Fujifilm, to a big corporation in Japan. And from that moment on, everything was dead because it was only about Excel sheets, risk management, who was make the decisions, boards were defined of making decision boards and whatever, and nothing happened again. So that's why I also see in Tesla, when we talk to the people from Tesla, they're very different. They have a startup mentality. When you talk to people from Volkswagen or BMW, exactly, it's about their career, the positions, politics, who will get more power within the company, what are the current things that are important, and not about delivering a great product. And then you go into a car and sometimes I drive an Audi from rental things, and you have to click 6 times on a display before you can start the car because you have to acknowledge this and this. So nobody thinks about how do you use the product, how will it work, and it's more about not getting fired and having everything in there and covering your ass. So that's a huge problem.
Yeah, I totally agree, and I see the same things with these larger organizations. And I've even come across people who work at these traditional OEMs, and they're like, yeah, I get paid a lot of money and I work 15 or 20 hours a week. They're on some sort of advisory investigation group where they're looking at new technology. And I'm like, and they're proud of it. And I'm like, what? It's just waste,
So diving deeper into Tesla.
Yeah. So I think one interesting aspect about Tesla is this higher level of vertical integration that they are trying and also accomplishing already. So can you maybe introduce this to our listeners? So what is the difference there compared to like established players like GM or so, who I think approach this in a very different way?
Yeah. So this starts with the OEM supplier relationships. So over the course of the past 30 years, there's been a great outsourcing in the US automotive industry where OEMs used to make their own seats and instrument panels. They would build them up in the plant. And there was a big push to get earned hours per vehicle out of the plants, meaning having subassemblies built offline. Then there was the rise of the tier ones. So you have Bosch and Magna and Continental, and there's a half dozen others that are very large that can almost provide the whole vehicle. I believe Magna is a tier 0.5, and they're building the Fisker for Fisker. So what happens is all that brain power goes out, and the tier 1 suppliers are motivated by making good parts, high quality parts, but also they're not motivated for an elegant solution that shrinks their total cost to the tier 1. So what happens is You can see it in thermal systems. It's the best. The early thermal systems for EVs, the Chevy Bolt, was made with commercial off-the-shelf components. So pumps and valves and bottles and then lines. So if you look at a Chevy Bolt, it's a quagmire mess of lines running all over. They have 3 separate thermal systems, one for the battery, one for the cabin, one for the high voltage electronics. The supplier of that thermal system parts, the OEM, is motivated by selling things they've already created and not innovating.
And selling many parts.
Selling many parts that are high quality. They're all high quality and they're all low cost. But when you have 100 high quality, low cost parts and you add them up, they weigh more and cost more than an elegant solution that doesn't exist because you didn't put the effort in creating it. So that's where Tesla, with their vertical integration, created something called the Super Bottle in the first Model 3s, which has since been obsoleted. The Super Bottle was so amazing because it emulated nature. And what I mean by nature, it had both pumps, all the valves, the chiller, and the level sensor all integrated into one unit, like a heart. So if you think of your heart, you have the chambers and the valves, and it goes out to all the different places in your body. It looked like a heart in the shape of it, and all of the ports were integrated into the Super Bottle, and they were pointed in the correct direction. There was no lines going forward, back, right, and around. And every other vehicle we've torn down, a Hyundai Ioniq, even the Prius or BMW X5 hybrids with these complex thermal systems are loaded with commercial off-the-shelf components configured in such a way that they have horribly inefficient routing of the lines. And what you get is more fluid. If you have more fluid, you have to heat it hotter or cool it colder. You have to pump it harder, pump it further, more bends. It just becomes a more complex system that requires more fluid, more thermal capacity. And that vertical integration you talked about, if you're completely vertically integrated, you can design your system with bespoke pumps, bespoke parts, and it becomes so efficient that then you have it build to print. And that's what Tesla does. Tesla has suppliers. They design it, and then they have suppliers build their design. And what it results in is an incredibly efficient design from a weight perspective. But something that Tesla is not, they don't do everything well. Their vehicles are relatively low cost, and they're not feature rich. So I drive a GMC Yukon, and I prefer driving my Yukon because the seats are real leather. I have heads-up display. My cluster is a beautiful OLED, screen with a bunch of stuff displayed. Now, it's a diesel vehicle, and yes, I don't drive an EV, but I prefer the HMI, the human machine interface of my turn signals and everything in my Yukon. So Tesla, knowing that it's very hard to make a profit in an EV, they rightfully have very little content in the car. It's not that feature rich. They're pretty basic cars. Even the Model S Plaid, which does have a few extra screens and the seats are a little better here and there, it's not a Maybach and it's not a BMW 7 Series. And it also doesn't cost that much. So I think that the Lucid is actually slightly better of a halo car from an efficiency perspective, and the performance is almost on par, but the price point is higher. So I know a lot of focus is put on Tesla, but they do the things that people don't see well. Like, nobody buys a car because all the high voltage electronics are really well integrated, but they do that so that the price can be low and they can make a profit and they can thrive as a business.
And that's an interesting part because Tesla Automation, just by chance, because they acquired a German company, is a 1-hour drive from here with a car, and they build the machines that build the machine, and it's quite impressive to see how then they also optimize the production in the next generation. We hope that a new Model 3, Model Y is around the corner, where then again the production is so much more efficient. And that's then the game changer, because they can lower the price, offer vehicle pricing, and still make a lot of money. So that's the big difference.
Yeah, and I think there was a study put out on the number of hours it takes to build a Tesla, and it was, I think, below 50% of what a traditional OEM builds an internal combustion engine vehicle. I think it might have even been 33%.
Yeah.
And that you get there with the Giga castings, which drastically reduce your build time in the body shop, the structural battery pack, which allows you to install the seats and center console to the structural battery pack and deck it all at once. And then the fact that you don't have an exhaust and fuel system, which were complicated on internal combustion engine vehicles, is helpful now that you can deck a front rail cradle and you're typically only connecting one high voltage line, a low voltage connection, and then for the front, high voltage and low voltage connection. So, and then thermal lines. So very few connections once everything is decked. So it's just dramatically lowering the number of hours to build a vehicle at the assembly plant. I had the opportunity to tour Giga Berlin about 2 or 3 months ago, and the line was running very quickly. And I think their takt time was about 45 or 50 seconds per vehicle, which is good. But the plant was not that big. And people sometimes forget that one of the most complex aspects of the vehicle is the battery. 4,416 2170 cells in a 2170 Model Y pack, that it's very complicated to assemble, highly automated, typically done in Nevada. And all of that operation is essentially supplied. And Tesla manufacturing their own cells with the 4680 is very rare. I just saw a chart today. I think almost all OEMs rely on a partner to manufacture their cells. Even Ford with SK and GM with LG they're heavily reliant on those technological partners to build their cells.
Yep. So before we dive a little deeper into the batteries, can we maybe talk about this one technology that you already mentioned, the Giga presses? Could you explain to our listeners, first of all, what this is and why this is so special? Because we agree that this is probably one of the key innovations that Tesla has introduced to the automotive industry, and how likely it is that others will be able to copy this over the coming years.
Yeah. So the use of large castings in automobile bodies is not new. BMW, Cadillac, Land Rover for years have been using relatively large castings for shock towers in the front of the vehicle or for the rear wheel well area. So the Giga casting, the reason why that's important is because it took the cast parts and made it so large that it's now the full width of the car and envelops the full height of the shock tower. Plus, its fore aft length goes all the way from the seated position in the rear of the vehicle to the crush can. So the size is massive, integrating hundreds of parts which were previously stamped steel or stamped aluminum. And this is in any vehicle. This is not just Tesla's, but also any vehicle. It would eliminate all those parts. The problem is the old method of manufacturing these parts. You had incredible propensity for warpage and problems for manufacturing the parts, and then you had to heat treat these castings.
So this is a material science problem.
Yes. Tesla solved this with their material science group, which is a collaboration, I believe, between SpaceX and Tesla. They developed an alloy that they could cast these massive parts with relatively high quality and not needing heat treat. They only need to go to be degated, desprued, and some light machining. afterwards.
Mm-hmm.
Now, when
sorry, go ahead.
Yeah, and when we visited Texas, Sandy and I saw rows and rows and rows and rows of the castings for the front and rear of the Model Y. And now they have even bigger castings from 9,000 ton machines for the Cybertruck, which are they're huge. They're very, very big. And I think there's 3 major castings. There's the front casting and then 2 on the sides for the Cybertruck.
So they don't do the back yet.
They do the back, but I think that it's the left side and the right side in the back. And from all the photos they've shown online, it looks like the crosscar at the rear of the cab is a stamped steel weldment.
Mm-hmm. And how far do you think they can push this? So will it be possible to at some point basically gigapress the entire lower part of the car, like the entire, or is this unrealistic? So are there some constraints?
It is possible, but these are the constraints. So I visited Idra and I talked to their whole team, and they manufacture some of the largest presses in the world.
They're from Italy, right?
Yes, yep. In Italy, in Brescia, Italy.
Mm-hmm.
And the machine becomes so large, it becomes difficult to ship to like.
So that's the limiting factor.
Yeah. And so physics is not the limiting factor. The machine becomes so large, you may not be able to build a machine and then ship it and reassemble it. It becomes complicated. This isn't exactly what they told me, but once I'm in there and I saw how big it is, it becomes a very heavy, wide load. And maybe you're limited to ship, building it by the sea and shipping it, by freighter. And I think it gets complicated, but I think physics is the limit. And as long as the physics still makes sense, there's nothing really keeping you from making a 12,000 ton or 15,000 or 20,000 ton press. And, you could potentially cast the whole thing. Yeah. They're already about a third of the way there.
So next Gigafactory will be in Italy. Just kidding.
No, I don't think so.
No.
Okay. Do you want to take the next one on
Go ahead.
So I'll take that. Okay. Yeah. Then another very interesting aspect of Tesla's vertical integration is actually the electronics within the car. So starting from the inverters, but all the way to the chips, the semiconductor chips that go into the car.
And switching the voltage for the first time.
Yes, and actually, I think in the Cybertruck, they want to increase the voltage to 48 volts now, right? If I remember correctly.
Correct.
Yeah.
Yep.
So can you tell us about this aspect of their design process and how this again compares to established OEMs?
So I can't talk too much about the design process because I was never there, but I have talked with one of the circuit board design engineers. He was at an event that I was at in California, a really nice guy. And they take a different approach to when they're designing their architecture because they want to control as much as possible. And Jim Farley actually made a really great point. He was interviewed on another podcast, one of them from England. And he said that the biggest problem with being a software-defined vehicle is that a traditional OEM doesn't own all the different modules throughout the car. Tesla doesn't either, but they own enough where they can control most of the features through software.
And I think in the Cybertruck, they want to go to beyond 90%, right?
85%.
Or 85%, yeah.
And then 100% on their next one. So Cybertruck will be 85%. I think the Model 3 and Model Y are somewhere 40 or 50%. There was a presentation that showed how far they're getting. But then the design of the boards themselves and the iteration, that's what's really amazing. So we tore down a 2018 Model 3, and there was these boards on the each of the 4 modules in the battery. They're about this big, called BMS boards. They were relatively highly populated, and they had 5 different temperature sensors on the board. The boards were pressed flush against the battery, and they sense the temperature in those 5 spots. So no wiring going to a separate sensor. That it was on the boards. When we tore down our 2020 Model Y, the board had been depopulated down to 2. So they were only monitoring the temperature in 2 spots. So it's that type of rapid innovation. It's not necessarily innovation. It's once they collected enough data from their 2018 and 19 Model 3s, they said, all right, we no longer need 20 temperature sensing spots. They then went to 2 on each. So it went to 8. So it went from 20 to 8. A tiny cost savings, but because they control their boards and the production of their boards, they're not locked into a 7-year contract with a supplier that's selling a black box. And that's what happens if you buy a Continental radar unit. You're getting a black box. They make that same radar unit and circuitry for a lot of OEMs. So if there's refinement that can happen in the hardware, you have to wait until the next iteration from that supplier, and then you're paying a premium. And we've seen examples of Tesla continually changing and improving the architecture of the boards or the chip layouts over the course of the last 4 or 5 years.
Yeah,
and
I mean the drawback if you do it that way is you have to, or I'm not sure if it is a drawback, but it's something that you need to worry about, is getting all the expertise in-house, right? And this is a challenge probably.
But if you are Tesla and you can hire the engineers because you're the greatest place to work at, that's a competitive advantage. Just exactly those engineers want to work at Tesla.
Yeah, Frank, you made a great point. I heard there's some stat. There's 150,000 employees at Tesla, but 3.5 million people applied for the job. They have a massive draw.
And that's, for us as investors, one of the most important things, because we want to invest into the future, into a great company. And attracting this talents, we see it in our venture capital portfolio, is very, very tricky. And there is still, even these times, war for talents. And Tesla has this, and SpaceX has this magic thing where people want to work, and that's the advantage. And then you can design your own boards.
Yeah. Yeah, agreed. So there are 2 more technical topics that I would briefly cover here. So the one is the whole topic around batteries, and the other one is autonomous driving. So maybe if we start with batteries. So can you tell our listeners about this innovation that Tesla is currently trying to implement, this 4680 cell, which they presented at Battery Day, I think in 2020 or so, for the first time. Yeah. So can you tell us about this? So what does this actually mean, like 4680? What does this stand for? And why is this so different from what other people use?
And will they succeed?
Yeah. And where are they currently? Yeah.
Yeah. So the 4680 is the dimensions of the cell. So it's 46 millimeters wide, 80 tall, just like 2170 is 21 wide, 70 tall. And 18650 is actually 18 wide, 65 tall. So it's the form factor of the cell. The reason why the 4680 is important is not for performance reasons, it's for cost. It's the economy cell. And the reason why it's the economical cell is because you get more jelly roll, more active material per battery and less can. And by can, I mean the stainless steel can. And the cans are also thicker, and they can contribute to structure. The way that they're designed, they're able to be closed in and glued together in a way that allows them to contribute to the structure. So the 4680 cells also reduce the number of connections, because you typically need about 850 cells to get a roughly 75 kilowatt hour pack at 400 volts, which means you have many less connections because you're connecting just to the positive and the negative on those cells, versus 4,416 2170s in the same Model Y or Model 3. And if you have a larger vehicle like a Rivian, it can be well over 7,776 cells. So you reduce the number of connections, which is an advantage. You're also passing more current through each cell. Typically 9 or 10 are in parallel instead of well over 30 or 40. So each cell handles more current. And then the process by which they're manufacturing is a dry process where they're not using solvents and drying ovens. And they've really only perfected the dry process on one half. When we visited Tesla in 2022, they mentioned that they were only sometimes getting I forget if it was the anode or the cathode, but they were only sometimes using the dry process on the anode. And that's really the holy grail, is they're able to manufacture the cells in the plant itself. So you then eliminate the shipping of the cells from South Korea, if you're working with LG or SK, or from the cell manufacturing plant. And that's a tremendous cost, is just shipping the weight of all the cells to the manufacturing plants. And the reason why the 4680 is really important is because it allows the pack on the Model Y, structural pack, to have 0 threaded fasteners. None. 0. And we tore down a VW ID4 battery pack, a Ford F-150, Mustang Mach-E, a Rivian. They are loaded with hundreds, dozens and dozens and dozens, maybe well over 100 threaded fasteners, large ones, M6, M8, M10 bolts, securing all these modules together. And Tesla is eliminating that. They're choosing reliability over serviceability. So many times modularized designs introduce failure modes through more connection points. So if you have 18 modules, you have 1-2 connections per module, is an opportunity for error. It's an opportunity for a cross thread. And Tesla has eliminated as many of these opportunities for error by choosing reliability over serviceability. So would you be able to service a 4680 cell? Never.
Yeah, actually, I remember watching this video of yours where you tried to tear down this structural battery pack of the Model Y, and I think it was like a week-long process for you, right? To get
1 month.
1 month, yes.
1 month. We tracked the cost of that effort, and it cost $30,000, $30,000 US to fully disassemble the battery in labor and equipment and tools. Because we're paying our people. We also were very careful, and we ended up coming out okay, because I think we were the first people to get that pack apart. So the amount of reports that we sold on that pack was incredible. Yeah, and it paid for.
I mean, so the question is, do you believe they will succeed? So do you have a strong opinion on yes, they will do it, or do you say, oh, there's still some things left that they will really succeed?
Yeah, that's a great question, Frank. I think they're behind schedule.
Definitely.
They made an announcement earlier this year that they had just made 10 million cells. And they were proud of that, 10 million 4680s. I did the math real quickly, and that equaled essentially 11,000 vehicles worth of cells, which is not very many. Mm-hmm. And I think the 4680 cell production will be the limiting factor for the Cybertruck production. I think that's part of the delay is they haven't really quite gotten it right. Their things that they claimed on Battery Day, the energy density, they're not quite there yet. I believe they're in the low 200s for watt hours per kilogram.
On a cell level.
And on a cell level.
Yeah.
And they need to be closer to 250 to 280 watt hours per kilogram, which is more where the 2170's at, in order to have the cell have enough energy density to make sense over LFP. So LFP is a really good choice for lower energy density per unit kilogram or area. And with the 4680 being in the low 200s, I believe it's not as advantageous as they had hoped. And it'll be interesting to see if all of the Cybertruck structural battery packs are 4680, or if there's a contingency plan to have other cell form factors contributing to the structure in the Cybertruck. That's really the wild card. And so, Frank, that's a great question. I think they're still working through a bunch of stuff and haven't quite realized all the potential they had hoped.
But you believe they will get there? So the physics, they will find, or is it still a risk also where they say, we tried, but it's only at 240 and it's okay for some cars, but...
I believe that it will always be the economy cell. So it's important for the high runners, like the vehicles that don't have the max range, because if they need max range, they'll be using more exotic chemistry. If you need high performance, 4680, the 46 millimeter diameter is too big for average mean distance to center for thermal properties. And you'd actually be better off using an 18650 that's why 18650s are still used in the Model S Plaid, is because the thermal properties are better.
Perfect. Okay. Yeah. Then coming to the final big technical topic, autonomous driving, FSD. I mean, we're following this closely, obviously, and I think this is the $1 billion question. When will they solve this, right? So when will they reach level 4 or maybe even level 5? So could you maybe first of all explain to our listeners, how is Tesla approaching this differently from other OEMs, and where are they currently standing in your view?
I take a reverse approach to this question. The problem isn't whether or not the technology is ready. The problem is the environment that we deploy the technology is surrounded by humans who make mistakes. Whether that's humans crossing the road when they're not supposed to, humans driving poorly. And it's incredible. All of the edge cases, almost all of the edge cases are because there's some sort of human, a car accident, and then there's emergency vehicles on the side of the road. So humans interject all sorts of edge cases into the scenario.
Or a car sign sitting on a car and then driving because it's loaded on the car and it's not a car sign, not a sign that's just standing on the road.
Yeah. And there's many edge cases. So I believe it'll take decades and decades before you have an environment where the edge cases become more and more rare. But right now, I've ridden in several vehicles that have FSD. The first time I ever did was in Silicon Valley with John from Tesla Silicon Valley. It was a very early version of beta, and it was super impressive because it was driving aggressively. And since they've rolled it out to the masses, some of that aggressiveness has actually come back. And I actually like the aggressiveness because it was changing lanes quickly and being decisive. So they have the ability to have FSD be a more aggressive, decisive driver. But when deployed in the entire world, it becomes more passive and reactive and protective. And I guess your question is when. I think the technology exists. The processing power is adequate. The hardware is fine when it comes to cameras, radar, and LiDAR. The environment is the wild card. The humans in the environment and the edge cases are not are still too wild for it to work correctly. And a passive controlled environment, there's almost no accidents. If you put an EV in a closed off city where it's all controlled, the vehicles perform perfectly fine. Yeah. And when you have humans interjecting these crazy edge cases, it just makes it very difficult. And I think Tesla's doing a good job of learning and sending back those edge cases to their Dojo computer to process. other OEMs only have their systems work on certain highways and streets, which I think doesn't work. You have to have the system work on a gravel road, on a dirt road in the middle of the country with no lines, because you'll enter scenarios where some human has made a mistake marking the line, or they ran over a stop sign and now the stop sign doesn't exist. So these edge cases are they become difficult.
Yeah, and you mentioned the sensor suite that people use. So I think this is maybe even a contentious topic, right? Because Tesla at the moment uses only cameras, some radar. I think in the Hardware 4 platform there is some space for radar. I'm not sure if they're actually putting it into the cars at the moment, but anyway, basically they decided, or they opted to not use LiDAR. Can you tell us about this decision? What's your feeling there? I mean, basically everyone else in the industry agrees that you will most likely need LiDAR, right? So, and they are the only ones not using it. So why is that? And what's your opinion on this?
I think initially it was cost. LiDAR is more expensive than radar. And then conveniently, Tesla removed the radar unit during the chip shortage. Do you remember?
Yeah.
It was a chip shortage, and Tesla was still delivering cars at a rapid pace without the radar unit. And then shortly after, I believe maybe 6 months to a year later, they removed the ultrasonic sensors from all their vehicles. That is a massive cost savings. You're talking $1 billion a year removing those ultrasonic sensors. We did a video on this. I added them up. There's 5 in the front and 5 in the rear, the wire harness, all of the paint, color, chips and everything. And it wasn't that much money. It was, I don't know, $30 or $40. But once you do the math on all the vehicles they make, it was several $1 billion. So does a consumer like having ultrasonic sensors when you park? I do. But ironically, my vehicle was delivered during the chip shortage, my Yukon. It has the sensors, but I don't have the module. It's actually going to be installed on Friday, and I already have 25,000 miles. My Yukon is 220 inches long. I don't know how many meters. Was that 3.5 meters long? And when I park in the United States, I rely solely on the cameras because it does the top view. It's really nice. And so are ultrasonic sensors unnecessary? And Tesla decided, they do have some value in some scenarios where you're getting really close, but I think vision suffices. And if you want to truly thrive as a company and be profitable, that was a several $1 billion decision. So I think cost comes into play a little bit when it comes to the sensor suite that's used for ADAS, because Tesla spends a tremendous amount of money, well over $2,500, I think $3,000 for the ADAS board. So they're giving away $3,000 worth of processing power on every vehicle.
Yeah.
And only, I think, 14% of people pay for FSD. So 86% of the consumers are driving around a Tesla with the capability of FSD, but they've never paid for it.
Mm-hmm. Do you think the regulator might demand certain sensors? So is it possible that, I don't know, the US regulator will say you will have to have at least, I don't know, 2 different types of sensors for redundancy or whatever, or in the end it's going to be just whatever works?
I can see that for level 5 and 4.
But this would be a problem, right, for Tesla, because then they would have to add LiDAR back in, or...
But level 3, the reason it needs to be for level 5 is because if you have an extreme dense fog, a human struggles to drive because we are vision only, right?
But you could also say then in this environment, you have to stop the car. You say, because so then you still can be licensed, but you can't drive. It's like IFR with the planes, so that's a big differentiation, whether you fly visually, VFR or IFR, and that could be kind of the same with the car.
Yeah.
So closing up, one big question for me is when you look at Giga Mexico and the next generation, the Model 2 and so on, and what could the team we just discussed, or they could decrease the cost and gain more efficiency. Is there a player that you see can cope with that, can be a good competitor? Or is it like if you want to have a good, not the best, a good electric car that's produced in scale, Tesla is just a winner like Google was in search? How do you see that?
I think what Tesla's doing in Mexico is necessary to compete on cost with China.
Okay.
China has several economic advantages that are disassociated from the designs of their vehicles, whether that's relationships with their government, subsidized property, subsidized manufacturing costs, subsidized steel. There's governmental incentive that China has given to many manufacturers that allow them to make their vehicles at a much lower cost. Whether that's low-cost labor, they have a really robust battery manufacturing. This is China, battery manufacturing ecosystem and industry. China's advantage is incredible. Where they're really lacking is they lack that final 5 or 10% of refinement for European and U.S. market vehicles. The consumers are a little different than the Chinese market. But I believe the Chinese OEMs are going to start to penetrate Europe first, and they will win on cost if traditional OEMs make vehicles the way they always have. So Tesla builds in China their Model 3, but they build it with the traditional design that they've designed their Model 3 for the United States. The vehicle, the unboxed vehicle, the Model 2, with the compartmentalized assembly process, the gigacasting in the front and the rear, structural battery pack, reduced. I think they're reducing the manufacturing cost by 25%. That's incredible. And it's necessary for them to build a vehicle and sell in other markets and compete with China. I think that is it. I don't think they're trying to build the vehicle to make even more profit in the US market. I think they're building so they can sell the vehicle in South America, so they can sell the vehicle in India, so they can sell it in Southeast Asia and compete with the Chinese vehicles. And China's cost advantage is, I don't think, necessarily associated directly with how they design their vehicles. I think there are other factors. But the U.S. government also subsidizes manufacturers in other ways. They give them loans to build battery factories. There's the $7,500 credit in the United States if you buy an EV. So it's not that the U.S. government isn't helping OEMs in some ways. They are. But it's typically related to cars in the United States. I think this is a global play. They're going to build in Mexico, which has more friendly export relationships with other countries and continents. And I think it's a bigger play than just the vehicle itself.
Makes sense. Yep. We are running over time. Thank you very, very much for this discussion. We learned a lot. Looking forward to learn more from you, whatever is your new role or your new things. Maybe you write a book, maybe you start a podcast. You have learned so much over the years, and we really enjoyed learning from you on YouTube. So it was a pleasure today talking to you. Thanks very much for your time.
Yeah. Thank you, Frank. Thank you, Richard. I had a great time.
It was great meeting you, Corey.